Good morning, class. Today's lesson is about acid and base titration. And what you see here on the picture slide, the title slide, is a picture of a laboratory procedure that I always like to carry out when we do acid bases. Now, if we are able to get back to school sometime this semester, I will make sure that we carry out this lab because it's a very important chemical process that's helpful in determining acids and bases concentration. When we're talking about titration, we need to understand what it actually is. Titration is the analytical method in which a known standard solution is used to determine the concentration of another. So what this means is that any solution that I know the concentration already is called the standard solution or the known solution. Now, obviously, if it's called the known solution, that's pretty easy. We know what it is. But a lot of times in these problems, they'll talk about a standard solution. It's standardized, which means we know exactly what the concentration of the acid or base in solution actually is. Now, when we're talking about titration itself, we're going to have an experiment, and we're going to take an acid or a base in which we don't know one of those concentrations. And what we do is we take a fancy piece of equipment called a burette. The burette's going to hold the known concentration solution. So if I'm doing with an acid and it's a known acid, that would be my burette. In the flask, in the bottom, I would be able to then have my unknown that I'm going to react. And what happens is we're going to keep adding a little acid to the base with an indicator inside until the indicator changes color. Let's get rid of that. So the indicator is going to change color. And when the indicator changes color, that identifies to us that the reaction is finished. That is the end point. And it does take practice because what we need to do is we have to understand that when this occurs, the lightest color is what we're looking for on the indicator color change scheme. Once it goes too dark, we went a little bit too far. So we always like to practice this a lot to get it down to the precise measurements that we need. Now, when we're carrying out this acid-base titration, we're carrying it out because all of this occurs because of the neutralization reaction. And the neutralization reaction, as you know, is acid-base gives us water and salt. And when this is done correctly, we hope that the resulting solution will be a neutral pH with a pH of 7. And in titration, when this occurs for us, we call that the end point. That's where the indicator changes color. But that also tells us, if it's a pH of 7, that the ion concentrations are now very, very close to being equal. We call this the equivalence point. This is where the concentrations of the ions, the H plus for acid and OH minus for base, are pretty close to being equal if they're not equal already. Now, again, in this laboratory experiment, we would have to do this several times to get very precise to that number. Again, it takes practice. For us, we need to know how to carry this out mathematically. And thankfully for us, as always, if it's a mathematical formula, we're going to find our information on table T. So let's take a look at table T. And notice table T has our important formulas and equations. And if you scroll down to this area called titration, take a look, titration, it gives us the exact formula that we're going to need. And even better, it tells us what each of the variables are. So when we're doing titration, knowing it's on table T, knowing that it tells us exactly what it is, we have to understand what the process is going to be. So Ma is our molarity of the acid, and most of the time, they're going to tell us it directly in the problem using the symbol of capital M. But if they don't give it to us and they give us some other measurements, we can use our solution mathematical chemistry to determine moles per liter. That was our molarity. Volume of acid, this could be either in milliliters or liters. Again, if the first volume is in milliliters, the second volume would have to be in milliliters unless they say otherwise. And then we have our base units, MB, molarity of a base, and we have our VB, which is the volume of the base. Now, in these problems, they're going to say either titration, giving it away, or they're going to say what's taking place, which is called neutralization. If something's going to neutralize something else, that's going to be an indicator, a hint that it is titration. So we're going to look for those things when we do our practice problems. Let's take a look. Take a look at example 1. Example 1 says a student wants to titrate. Notice they gave it to us right away. Titration, titrate. 15 milliliters of a 2.5 molar HCl solution with 10 mLs of KOH. What must the concentration of the KOH solution be if this amount was used in the experiment? Now again, practice with word problems. It's always good to underline the key components in the question. So notice here I have 15 milliliters of a 2.5 molar HCl solution. They give me 10 mLs of KOH, and they're asking me to find out what the concentration of the KOH must be. So if I take my underlined information, and if I'm not too sure what's an acid or a base, maybe I forgot, remember you could also consult table K and table L in your reference tables. Again, you should know by now what acids and bases are, but if you're not sure and you want to be 100% certain, check with table K and table L. So in this question, I know that the HCl is my acid, so the capital M is 2.5 molar, that's Ma, and then 15 milliliters is attached to it, so that's my Va. They tell me I have 10 mLs of KOH, that's my VB, and I'm looking for the concentration of KOH, which is MB. So knowing that this is a titration problem, I would have to go to table T, look up my formula, MA, VA, MB, VB, plug my numbers into the right spot, and notice because they're both milliliters, there's no need for conversion, and solve for the missing piece. So in this first example, I'm solving for the molarity of a base. So I'm making that X. So right now you should be on mathematical cruise control, as I always say, cross multiply, solve for X. When we solve for X, we're going to get 3.75 molar concentration. And when we do these concentrations and titration problems, we could make sense out of them as well, because HCl is a very, very strong acid, and KOH is a very strong base, right? One H, one OH makes it strong. We learned that earlier in the lessons. And notice that the amounts that we're using are kind of on the close side together, okay? But notice I have a little bit more of my acid, and I have a little less of my base. So that means my molarity is going to be pretty similar, close together, and they are 2.5, 3.75, not much of a difference there. Okay, let's take a look at example number 2. In example 2, a student wants to titrate 35 milliliters of a 1.8 molar NaOH solution with 20 milliliters of HNO3. What must the concentration of HNO3 solution be if this amount was used in the experiment? Again, I bolded titrate, telling us that it's a titration problem. Sometimes they'll say exactly neutralize or neutralize. That's another giveaway. But let me underline my key points. I have 35 milliliters of a 1.8 molar solution of NaOH. Now my brain is telling me NaOH, oh, that's a base. And then it says I'm mixing this with 20 milliliters of HNO3. HNO3 is my acid. They want to know what is the concentration of the HNO3 solution. So I'm looking for my acid solution concentration. So if I take what I underlined and I plug it into my MAVA chart, I'm looking for MA. VA is 20 milliliters. MB is 1.8 molar. VB is 35. So knowing it's a titration problem, I can pull up my titration formula. I can place my numbers into the correct spots. This time I'm looking for MA. And now I am on mathematical cruise control. I am solving for x, and I'm going to get 3.15. 3.15. Okay? Again, not difficult to do, but where mistakes usually occur in these problems is students put the numbers in the wrong spots. Okay, so you got to make sure you're careful. Last question for this lesson is example 3. And here we have a student that wants to titrate 55 milliliters of a 2.8 molar lithium hydroxide LiOH solution with 1.5 molar HNO3. What volume of HNO3 must be used in this experiment? So it says titrate. I know I'm doing titration. I'm going to underline my key things: 55 milliliters of a 2.8 molar LiOH solution. I'm using 1.5 molar HNO3. And this time, the question's a little bit different. It says, what volume of HNO3 must be used in the experiment? So I'm not looking for an M, I'm looking for a V. So I take my information, I set up my MAVA chart. This time MA is 1.5 because that's the HNO3. I'm looking for VA. My MB is 2.8 and my VB is 55. It says titrate. I know it's MAVA is equal to MBVB. And then I need to plug in my numbers in the right spot. Now, again, remember, this time we're looking for VA. So my X is going to be in the VA position. And when I solve for VA, I'm going to get 102.7 milliliters. Now, the only time these questions get a little more challenging is when they ask you something in liters, which means you have to convert. And then if we were doing some advanced chemistry, whether it's honors or AP, sometimes they'll use acids and bases that extra steps are included. But we don't have to worry about that. And this is titration. So as always, you're going to have your worksheet. You may want to do the worksheet as you're going through after watching this video a couple times. Do the questions, answer them, and then resubmit. Everyone, be safe, stay healthy, and I'll see you next time. Take care.